Okay, I was talking about threads. How do you define a particular concept if I am saying thread? Or if I ask a very basic question out of this context, uh, when I'm saying threads, then how would you explain if I'm saying there is a process or there is a thread? So, what is the difference between process and thread? Let's start from this discussion. Anyone would like to explain? Anyone else? Okay. Anyone else? Please participate.
Thank you, Priyanshi.
Let me explain you. It is very important to understand thread before proceeding it up with the virtual threads in the modern Java. Think of like there is a restaurant system. A process is the restaurant, and thread is a worker inside the restaurant. For example, a restaurant has a kitchen, a staff, or tables or resources. All works independently, self contained. But a thread is a worker inside the restaurant. So, someone said rightly, process is a group of threads. Thread is a smaller sub program or smaller execution. Please don't copy the statements from somewhere. At least for 2 hours, just leave everything, the AIs and everything. A thread is like a chef or a waiter inside the same restaurant because multiple threads share the same kitchen, same resources, and that makes the application lightweight and cooperative. So, in short, process may have multiple threads inside this. A thread is a smaller unit of execution where the process is the independent program. Every process will have a separate memory, but the threads have a shared memory depending upon which technology you are using. If you are using Node.js, then there is an event loop that will use the same memory. And if you are using the Java or something, there is a concept of multi-threading. Intentionally, processes are heavy because it consists more threads inside that. So that's what it is heavy. Threads are lightweight as compared to the process. So process means, let's say, running a Java program, and thread means running one specific task inside that. How does that work, guys? Each thread is mapped to an operating system thread managed by the OS scheduler. There is a scheduling algorithm might you have gone through with, and problems are there with the traditional threads that we are using as of now. That is expensive to create, limited in number, whatever, few thousands maximum. Context switching is very high, cost of the context switching is high. So for example, in real words, if I talk about, and if I'm using a traditional multi-threading concept, one waiter equals to one customer. If waiter waits for the food, he is blocked. That is also known as synchronous programming. So need many waiters, and it will be high on cost and the poor scalability will be there. But in Java 21, there is a concept of virtual threads. Virtual threads are lightweighted threads managed by the JVM, not the operating system. Please mind my words. The traditional threads were managed by the OS scheduling. Thousands to million possible because of the concurrency. For example, if we are creating a waiter system in the restaurant, few real waiters are there, that is OS threads, and few virtual waiters are there, which are the task. So when waiting, task is paused, real waiter serves the someone else, while the virtual waiter keeps on tracking where the order is ready or not. Nowadays, whatever outlets you see KFC, you see Starbucks, you see MACD, all are working with both the waiters, the real waiters and the virtual waiters. Real waiters serves you, virtual waiters keep tracking the order, whether when the order is ready, they will pop up the order number over the screen, it will be flashed it out, and you will get a call. You might get a call back, either the data or the error. For example, I ordered for something and that cheese is not available or that base is not available for the pizza. They will call you back with the error that sorry, this thing is not available. So maybe some person, your order is getting ready. Meanwhile, someone came and say, I need a water bottle. Obviously, water bottle not need to be prepared, so they will immediately get served. So that will be depending upon the availability of the responses which are getting ready. So the key idea of using the virtual threads are don't block the thread, suspend the task if taking the long time, or just evaluating with the right condition. So that's how the things works. Let's try to understand with the help of the code. Okay, I have a order class already, creating a list of order. I want to iterate the order. Okay. What I really wanted to do here is, in the case of old approach or traditional threads, I want to create here executor service. Okay. While iterating this loop, I just want to call a submit. It's too much. And after that, I want to make my executor shut down. Okay. While processing the order, also, I'm not writing too much code here. Okay. Now let's understand this. If I'm writing this piece of code where I'm going to write this old approach, this process, this iteration says that I'm going to create a list of orders, and this list of orders are getting ready. And whenever I want to assign it to the threads, or I could say that the traditional threads, this is a very traditional thread process which I'm going to create here. So when I'm writing the executor service here, it means you are creating a pool with two threads only. So there are two real OS threads. So maximum it can hold two tasks run in parallel and remaining tasks go into the queue. That's how the pool works. And imagine, for example, there are two delivery boys and 10 orders. So only two orders processing at a time, others wait in a line. I think everyone has faced this iteration in the real life scenarios. For example, I ordered the medicines. I generally, whenever I order manually, if I'm not going to order through the app, they tell me that delivery partner is busy and they will quickly deliver the things to you. It means the pool is less and the requests are high, demand is high. So when I am saying that I have a list of orders, just the sample data that I'm having, each order considering the one task here. Okay. So when I'm saying that executor dot submit and process the order, the submit method here wrap the task into the runnable interface. I'm not going forward and telling you how to create the thread and what is runnable. Send it to the thread pool queue assigned to a available thread. So if in case the request has been submit for the order 1, order 2, only two requests can be processed at a time. Order 3, order 4 and order 5 has to wait. I'm not saying that in a sequence it has to be followed. The sequence may change. So what will happen? Task 1, thread 1, task 2, thread 2, task 3, task 4 and task 5 waiting. So that's how the processing works. So executes by the worker thread. This is how the submit method will assign the process order to a particular OS thread. So in real calls, in real applications, when you use a DB calls, API calls, or file IO, uh, this really pitfalls behind, and the executor dot shutdown will stop accepting the new task and complete already submitted task. So there are the limitations with this piece of code. As I have said to you, you created only two threads, two pools. So if 1000 orders are there, there is a bottleneck. So if the process data or if the process order blocking a particular request, let's say for a particular sleep I'm keeping here. For example, if I really don't want to write this very simple and I want to make my code sleep also, I can put on the thread sleep and all. So this is simulating the time taken to process. I need to wrap it inside the try catch. That is completely fine. So if your particular thread is taking time, the thread is completely blocked. So this is again the blocking cost is high in this piece of code. And each thread uses the memory, let's say 1 MB stack or something. So OS scheduling is again overloaded or overhead, cannot scale to the millions. So visual execution is very clear that I have 5 orders, but I am creating 2. So 3, 4, and 5 has to be in the order. So how does differ from the virtual thread? How the virtual thread keeping the things iterated? Let me explain you right there. So what you need to do here is, first of all, let's convert this to the virtual thread and try to understand how does it work. Just keeping the code right there to implement the virtual threads. So whatever executor service you are creating, you are writing new virtual thread per task executor. The list will remain as it is, the order loop will remain as it is, the shutdown will remain as it is, and the process order will remain as it is. So you can now create a thousands and millions of threads only. Let me explain you why. So virtual threads are lightweight threads managed by the JVM, not by the OS. So traditional threads are heavy because they are the OS managed threads. Virtual threads are lightweighted because they are the JVM managed threads. You can create thousands or even million of virtual threads at a given point of time. So when I'm writing this line, that new virtual thread per task executor, it means it creates an executor where each task run on a new virtual thread. No thread pool size limit like traditional executors. So what happened when you even write the list and you are going to iterate this? This not has to be written here. Okay. This not has to be written here. This was to be writing here. I'm not sure why I have written here. So when you are iterating the loop here, each order is processed concurrently. Now, each task get its own virtual thread, and when you are going to shut down, it stops accepting the new task and lets the submit task complete. So what's the execution flow? The list is ready. The virtual thread executor is ready to get the threads. When you are going to submit the task, virtual thread number 1 equals to processing the first order, virtual thread number 2 is equals to processing the order 2, virtual 3, virtual 4, virtual 4, 5 threads equals to individually processing the order. So massive concurrency is there, minimal overhead is there. And why virtual thread pool is game changing? Because in a traditional thread pool we limit the threads like a thread pool, but there is no limit in the virtual thread. Create one thread per task, and it is cheap to create because it is being managed by the JVM and idle for IO heavy applications. So that's what you need to upgrade your implementations. For example, you are processing the order and your order is taking time, it will not need to hold it back. So all orders run in parallel. Even with 1000 plus orders, it will have a still efficient impact to the code. So that's how the clean modern approach works. We have so many things to be discussed. We can go with the try with resources option is there, that will automatically shuts down the executor. You do not even need to call the shutdown, but again things needs to be used wisely. And just one advice for this: avoid blocking the calls. And blocking is cheap and safe in the virtual thread, so you can go and manage that way and use the modern approach.